Hello everyone, this is Mrs. Duarte. Super excited that we get to have our own video for the class. This is the first video that I've made or am in the process of making, so let's go ahead and get started. Multiple representations of equations. What does that mean? This is the lesson for today. We're going to be looking at multiple representations of equations. That means we will see how we can represent equations in different ways. So we're going to represent equations in multiple ways. Let's look at those really quick. So we've seen equations that look like, for example, a line y equals 2x plus 1. We've all seen similar things. It looks like there's an equal sign in between. There is y on one side, x and some stuff on the other side. We've seen it looking differently as well. As long as it has the equal sign, it is an equation. Also, we've seen graphs where we have an x and y axis and then we have a line or a different kind of shape. We've seen word problems before where we take a word problem and we write something out of what it's telling us to come up with an equation. We've seen tables where we have x and y values with different values in that table, and we've seen we have not seen many patterns yet, and I don't think we've seen sets before, at least not in my class. So let's look into a few of those. Okay, here is our first pattern. So what I'm going to go ahead and do is first and foremost, right at the very top, let's write that pattern. I don't think it's letting me write properly on here. Here we go. Okay, so let's say I have this pattern, this one right here. I need to figure out what this pattern does, how I can convert it to look like a table over here, or like a graph, or even like an equation. Let's look into that. Okay, let's look at this pattern and see how we can understand what it's doing. So figure number 1. How many squares does it have? Well, let's look at the number of squares. We have 1, and then 2, 3, 4, and 5. So remember, this one is just me doing this problem. I'll try and remind you guys to pause to think about how we can approach things, but you will have 2 other practice problems that you'll be working on. So for this one, figure number 1, I'm going to count how many squares it has. It has 5 of them, and I'm going to write 5 right here. Now, figure number 2. I still have what I started with, 1, 2, 3, 4, 5 from the first one. But then I'm adding 1, 2, 3, and 4. So that's 9 squares on this one. For the third one, I have the first one, then the second one where I added the 4. So if I were to look at this, this is basically figure number 2. And then I added 1, 2, 3, 4. So let me go back and show you one more time how we get this pattern in case we missed it. So let me scroll back. All right, here we go. So the first one has 1 and then 4 around it. So that's 5 of them. The second one has the exact same thing that we had in the first one, plus 4 more. So that's 9. Now on the third one, it has the second pattern, the second figure in that pattern. Oops. The second figure in that pattern, plus 4 more again. Okay, this is just squiggly. It's not intended to be anything. Basically, if we were to color it to find out how many extras we have 4 more than the previous one, so that's 13. So let me go to the table here and write. Actually, before I do that, let me scroll down a little bit. And let me just clarify. I'm going to use figure number as my x values and the number of squares as my y values. So for the figure number 1, I have 5 squares. Figure number 2, I have 9 squares. Figure number 3, I have 13 squares, etc. Now, if I were to find my fourth figure, use this pattern, my fourth figure is going to be basically taking figure number 3, all of it. Let me use a different color. If I were to take figure number 3, then add 1 square on each side and keep going with that pattern. Figure number 4 is going to have 17 squares. Now, what if I say, get me the number of squares for figure number 5? Let me scroll this down a little. If I were to do this again, I want you guys to try and see what that would get me. So if I'm looking for figure number 5, how many squares will I have? Go ahead and pause, think about it, and write it down. All right, I'm hoping everyone paused for a second, was able to come up with the number. Now let me go ahead and first write this down because we had it in blue for figure number 4. So let me erase this and write 4. We came up with 17 squares. So now for figure number 5, I'm assuming you did the same. You added 4 to 17, and that's going to be 21. Now, what if I did not do any of that? And I asked you guys, what is the number of squares in the 10th figure? What if I said, I want you to find the 10th figure. How many squares does it have? Pause again for a second, think about it, and write it down. Make sure to pause, think about it, and then start playing the video again. Okay, now I'm hoping everyone tried to find the pattern on a larger scale. So let's go ahead and scroll up a little bit. Nope. So, come on. Okay, here we go. So, if I were to keep going with this pattern, I have to keep adding a square on each end in this manner, right? So every time we have 4 more squares added. But if I were to jump and I want to know what the next one is, I'll have to figure out the large picture. What is the pattern looking like? Okay, well, here we go. The very first one, actually, we can skip this one. We can say, okay, so this is going to give me figure number 1 plus 4 to it. Number 3 is giving me figure number 2 plus 4 added to it. So if I were to look at the first one, I can say, well, it's 1 square in the center plus 4 squares around it. Figure number 2 is going to take whatever is in figure number 1 and add 4 to that. So that's figure number 1, how many squares it has, and then add 4 to that. Let's look at the next one. Figure number 3 had whatever figure number 2 had, plus add 4 to that. So let's look at this again. Figure number 1 had 1 plus 4. Figure number 2 had 1 plus 2 4s. Figure number 3 had 1 plus 3 4s, which means that's really equal to 1 plus 4 times 1. So let's scroll down. This is really equal to 1 plus 4 times 2. I should not write it on this side because I'm squeezing the work. Let me add it to the other side. Okay, so I'm going to write it on this side. So that's equal to 1 plus 4 times 1. This is equal to 1 plus 4 times 2. This is equal to 1 plus 4 times 3. Well, let me point this out one more time. If you haven't noticed it, this 1 is because we're on figure 1. This 2 is because we're on figure 2. This 3 is because we are on figure 3. These 3 are connected. So let's see, what is the 10th one going to look like? Well, if I were to keep going and I want to find out the 10th figure, figure number 10, I want to know how many squares does it have? Well, it's going to have 1 plus 4 times, you guessed it, 10. Well, 4 times 10 is 40, right? So if this is 40, 1 plus 40 is equal to 41. So this number is going to be 41 right here. So I'm going to go back to the table and say, well, if I do have the 10th figure, that is going to have 41 squares. So now let's go backwards. What if I have, let me use a different color. Let's do blue. What if I have 65 squares and I need to know which figure is that? Which figure is it that has 65 squares? I need you to pause, think about this, and try and come up with a number right here to see if you can understand how to get to that figure. Which number is it in order for it to have 65 squares? All right, go ahead and think about it. Pause, then play the video again when you're done. All right, so let's look at this again. If I were to try and figure out which figure I'm working with to get 65, again, there is a number, the figure number, such that when I multiply that by 4 and add 1 to it, I'm going to get 65. That's the same thing as solving for x, right? This is a number, let me call it x. So I'm going to go ahead and call it x. Well, in this case, I really don't need the parentheses either. So let me just erase this and rewrite it as 4x. All right? So now that I have this equation I can solve for x, I need the y value, 65, so I'm going to solve for x, such that I will have 65 squares. All right, here we go. So first thing I'm going to do is subtract 1 from both sides. Those are gone, they cancel out. That was too perfectly aligned. I'm going to fix that. So 1 minus 1 is 0. I'm left with 4x on this side, and that's going to be equal to 64. Perfect. Now divide both sides by 4 so I can get rid of that, so I can solve for x. I will undo what was done here. So 4 times x is equal to 64 will imply that x is going to be equal to 16. Now I can go backwards and check it, but for now let me go ahead and scroll back up to the table. In order for me to have 65 squares, this number must have been 16, because the 16th figure is going to have one more than 4 times 16. So 4 times 16 is 64, plus 1 is 65. Perfect. All right. So now I can actually take all this information that I just did and find out what my equation is. All these things in each of the pattern description, like right here, 1 plus 4 times 1, actually, I'm going to undo that. It's on this side. This one, 1 plus 4 times 1 is the first thing that I noticed. And then when I scroll down, this one is 1 times 4 plus 2 in the second figure, etc. So if I'm on the x figure, my equation is going to look like this. Let me undo the arrows because they were not necessary to keep. I don't want to keep it crowded on that picture. Sorry, we have an airplane flying by. Sounds like it's low, so it might be loud around us. Okay, so here we go. My equation is going to look like y equals, so y is, again, the number of squares in the pattern. So the number of squares in the pattern will always depend on x, which is a whole other conversation. We will talk about dependent, independent again for you guys to review. Sorry. So y is the number of squares in the pattern based on which figure it is in the pattern. Okay, so let's go back to writing the equation. That's going to be 1 plus 4x, which is what we used earlier, or we can write it as y equals 4x plus 1. So this is the proper way to write an equation, and we want to use that format for equations in general, at least in this class, and in general in math classes. All right, with that said, I found the table based on the pattern. I found the equation based on the pattern. Now I'm going to try and plot it. So let me do this again. This is my equation, and let's go ahead and plot it. Y equals 4x plus 1. I can graph this line on the plot on the x and y axes, or I can just use the table to plot these numbers or in values. Okay, so where x equals 1 in the table, let me use red again since it was used in the table. When x equals 1, y is equal to 5. So here's my first point. And notice I only have one quadrant from the axes. That is because I noticed that all my values here are positive, so I don't need to have all 4 quadrants for the graph. I'm going to stick to one quadrant, the positive quadrant. So when x is 1, y is 5. Perfect. When x is 2, y is 9. When x is 3, y is 13, and so on. So now I can keep going, but they don't all fit on the table, but I will try and see if I can at least graph the line that will be going through these things. Perfect. So this is an approximation to the closest we can, given that I have the variable of using kind of like a pencil and a ruler in this case, but the ruler is on a tablet. It's not as easy to use as it is on paper. Okay, we have covered the table, the pattern, the equation, and the graph. This graph is the graph for the line over here. It's also the graph of this table over here. All of these will be representing each other in different manners, different forms. Okay, one last thing I want to add before we end this lesson is the following. Let me scroll down a little bit. I will write it actually right under, right here. Let me move this over here. I'm going to give you the set. Let me undo this. I'm going to use, I like to write the word set. In a set form, this set will look like this. If it was points from the table, it will be a set of coordinates. When x is 1, y is 5. When x is 2, y is 9. When x is 3, y is 13. Let me scroll. It's not enough room, but we will When x is 4, we said we're going to add 4 again, etc., right? We can keep going with this pattern. Is there a last point on here? Think about that for a second. A last set of coordinates. No, because this could keep going forever. We do have a very first point where we started, so we're going to use that as our first point in the set. Now, details on sets will come later, but for now, we covered the major area that we wanted to cover. Let me box this really quick so we can separate it from other things. So that's the set notation. Here's the equation notation. I'm going to scroll. This is the pattern right here. And then the graph and the table. I hope you guys enjoyed this lesson. We will be working on, let me go back to the scrolling format. So this is today's lesson. We will be using this exact number of things. We need to have a table. We need to have a graph. We need to have an equation. You do not have to create a set for each of these, but I would like you to try if you can. So the next pattern that I'll be posting as homework will be this pattern right here. You will do it on a separate piece of paper. In your notebook actually would be even better. Take a picture and upload it. I need to see a table, a graph, and an equation. And I would like to see your scratch work on the side anywhere. You could see it could get messy. So I want to see the work you did to get to these things, each of the formats. And then the last practice would be this pattern right here. This one is with rectangles. So you have to figure out figure number, then you write, this is my figure number 1, figure number 2, figure number 3, and then I need to figure out number of rectangles. How many rectangles does this one have? 1, 2, 3, 4, 5. So you write that down, etc. So you find that pattern, and then you complete these as well. The table for that pattern, you can ignore the center. I just couldn't fit the pattern in there. You will find me the number of rectangles, and then you'll graph that and tell me if you can find the equation for that pattern. All right, I hope you guys have a beautiful rest of the week. If you have questions, you know where to find me. Either email me or come to my office hours, and I'll help you answer the questions. All right, see you later.